In this video we will solve a problem on torsion. Okay, so this is the next problem. So in the previous video also we solved a 3 to 4 problems, but they are all different types, and this is also a different type of a problem here. Okay, so first we will read a problem and we will analyze. I'll read the problem here. Okay, so a solid cylindrical shaft, it is a solid here. The problem is related to solid cylindrical shaft, is to transmit 300 kilowatt power. The shaft need to transmit a 300 kilowatt power at 100 rpm. Okay, so first we will write the data one by one, what they are given. Data: the shaft is solid, the cylindrical shaft transmitting 300 kilowatt power. It will transfer a power P equal to 300 kilowatt. Convert this into watt because we need by calculation 300 into 10 raised to 3 watt. Okay, at 100 rpm, its speed is 100 rpm, that is n is equal to speed 100 rpm. It rotates at 100 rpm. Okay, first one, A, if the shear stress not to exceed 80 Newton per mm square. The shaft shear stress, the maximum shear stress not to exceed 80 Newton per mm square, find its diameter. We need to find the diameter of the solid shaft if the shear stress is 80 Newton per mm square. Therefore, again the given data is shear stress equal to 80 Newton per mm square. You need to find out what is the diameter of the solid shaft. This is the first A1. Okay. So go to the B. What percentage of saving in weight would be obtained if this shaft is replaced by a hollow one? It means he said that if you replace this solid shaft with a hollow shaft, what is the percentage of weight you can save? Normally, if a shaft is solid, its weight is more. That is normal consideration. If it is hollow shaft, its weight is less. Okay, so how much percentage of weight you can save if this solid shaft is replaced by the hollow shaft, replaced by the hollow one whose internal diameter equal to 0.6 of the external diameter. So I'll write what is the, if suppose W S is the weight of the solid shaft, and WH is weight of hollow shaft. If I take the symbols like this, the percentage of weights, it means weight of the solid shaft is more, weight of the solid shaft is less, right? So he is asking percentage saving in weights. So I will write weight of solid shaft minus weight of hollow shaft divided by weight of solid shaft, right, into 100. So this is the percentage of the weight I can save if the solid shaft is replaced by a hollow shaft, So I'll write here, for B, what is the percentage of weight? That is weight of solid shaft minus weight of hollow shaft divided by weight of solid into 100 equal to how much? He is asking in the B, second bit. Replaced by a hollow one whose internal diameter equal to 0.6 of external diameter. For hollow, he is given internal diameter is, that is DI, internal diameter I taken as the 0.6 of external diameter, outside diameter. So D is solid shaft, diameter of the solid shaft, DI is internal diameter of hollow shaft, D naught is outer external diameter of the hollow shaft. Okay, 0.6 of the external diameter, the lengths are same, the material and the maximum shear stress being same. For both hollow and solid, the lengths are same. So I'll write here the length of solid shaft equal to length of hollow shaft. He is given. Next, the material is same. For both cases, the material is same. That is weight density. Material same. Therefore, the weight density, whatever the weight density of both, it will be there. That will be same. Next, and maximum shear stress being same. And one more, he is given the shear stress of solid shaft equal to shear stress of hollow shaft. Okay, this is all the data is given. By using this data, first we'll try to solve a bit, that is we need to find the diameter of the solid shaft, then we will go for the b bit here. Okay, so this problem I'll erase and we'll start the solution here. Data we'll keep it as it is so that it will be helpful while solving the problem here. So solution, first I'll go for a bit to find the diameter of the solid shaft. Okay, so here is given power, the speed, shear stress, and we need to find out the diameter of the solid shaft. So what are the general formulae we can use here? In the previous we derived the equation, and in the previous video we solved 3-4 problems here. So general equation for the solid shaft, for the torque I will write here, that is torque equal to, for solid shaft, that is pi by 16 tau into dq. Okay, this is the general equation for the torque for the solid shaft. Okay, so where T is the torque, the mean torque, tau is maximum shear stress, and D is the diameter. Now check what are the available data given here. Okay, so shear stress is given 18 Newton per mm square, shear stress is there. So we need to find out the diameter of the solid shaft, but torque is not given anywhere in the torque. See here, he given power, he is given RPM, but he is not given the torque. So first we need to we will find out the torque, then we can find the diameter here. Okay, so to find torque, to find T, okay, use the power equation. Power in terms of torque, we have the relation. Okay, power, speed and torque we are using in engineering design here. So power, P equal to 2 pi nt divided by 60. These are watts, this is watts. Okay, so use this equation. What is the P power is given? 300 into 10 raised to 3 watts. 300 into 10 raised to 3 watts equal to 2 pi into speed. How much speed of the shaft is? 100 rpm, right? So 100 into, we need to find the torque divided by 60. Okay, so now this only one is the unknown data, torque. Okay, so simplify and find out the torque here. Okay, so after simplification, the torque value we'll get here, that is 28647.8 Newton meter. Normally this we will obtain in terms of Newton meter. Okay, so convert this torque in Newton meter to Newton mm, because all are in millimeters. So convert this. So this I convert 28647.8 into 10 raised to 3. 10 raised to 3 Newton mm. This is the torque. Okay, torque for solid shaft. Remember this torque, this will be helpful. Still we need to substitute in the further equations here. So once if you find out the torque, so where to go? Go to here. This I'll write it as equation E. Therefore equation A becomes So we know the torque, substitute here 28647.8 into 10 raised to 3 equal to pi by 16 into tau. Tau is maximum shear stress developed, it is 80 here into 80 into dq here. Okay, so in this equation how many unknown data? Only one is the unknown data, that is diameter of the solid shaft. So simplify and find out the diameter of the shaft, that is d equal to, so the diameter of the solid shaft is nearly equal to 121.8, that is equal to 121.8 millimeter. Okay, so that nearly equal to, I will take it as 122 millimeter diameter. Okay, so this is the first bit. We need to find the diameter of the solid circular shaft. So I'll get how much? The 122 millimeter. So these two I need. I'll write here sidewise the torque of solid shaft. Just I'll write torque of solid shaft is 2864 7.8 into 10 raised to 3. Okay, Newton mm. And diameter of the solid shaft is how much? It is 122 millimeter. 122 millimeter. These two we require for second bit. Okay. Now for B, we will go for the second bit B. What is asked in second bit? That is the percentage of the weight loss if the solid shaft is replaced by a hollow shaft. Okay. So percentage of the weight loss is weight of solid shaft minus weight of hollow shaft divided by weight of solid shaft equal to into 100. We need to calculate this one, right? So for that one, first we need to go to one by one here. Weight of solid shaft. Okay. So weight of solid shaft, I will write here. So weight density into the volume of solid shaft. This is related to solid. Okay. So weight density, this will be we use this formula we use in the previous the problem also. So density is mass by volume into volume. The volume it will cancels. We will get only mass, that is weight, into G, that is 9.81. So that's why we are using this formula. So weight of the solid shaft. So this I'll take it as weight density is the weight density of solid shaft. Just I'll take the specific weight into volume. So volume is volume of the solid shaft. This is solid, right? Solid. That is area into length, right? Area into length. Area into length. So this will be equal to, so weight density of solid shaft into area. Area of the solid shaft is how much? That is pi d square by 4. Pi d square by 4. D is this d into length of solid shaft, right? Length of solid shaft. This is weight of the shaft, the solid circular bar. Similarly, we will find weight of hollow shaft, because we need the weight of hollow here. Here also same weight density of hollow, that is weight density of hollow shaft. Just I am denoting like this, the specific weight of the hollow shaft into area into length, right? That is the volume. Area of hollow shaft is how much? What is the formula? Because hollow is inner diameter and outer diameter, di and d naught. Okay. So I took already here the di and d naught. Okay. So area is pi by 4. Here d naught square minus di square, right? This is the area into length of the hollow shaft. Length of the hollow shaft. Okay. Now substitute this here. This is equation B. Therefore B becomes, substitute. So weight of solid shaft is the specific weight, that is specific weight of solid shaft into pi d square by 4, capital D, d square by 4 into length of solid shaft. This is one. Next, weight of hollow shaft is the specific weight, the weight into pi by 4 into here. Just I'll write it flower bracket, and here also flower bracket here. So here d naught square minus di square into length of hollow shaft, divided by weight of solid pi d square by 4 into length of solid shaft. Okay. So now cancel the terms. Since the material is same, he is given the material for both solid and hollow, it is same. Its specific weight, that is weight density for both, it will be same. So here specific weight of hollow equal to solid equal to specific weight of hollow. So for this and this it will be cancels. Then pi by 4 and pi by 4 it will cancels. So lengths, he is given the length of solid shaft equal to length of hollow shaft, right? So length also cancels this and this here. So write the remaining term, that is d square into d naught square minus di square divided by d square, right? This is minus, here minus, sorry for this one, and here also minus we will get, right? Because this minus this here. So d square minus the d naught square minus di square divided by d square here. Now he is given one more, the inner diameter of the hollow shaft equal to 0.6 times outer diameter. Substitute here, that is d square minus d naught square minus, so 0.6 times d naught, right, square divided by d square. Okay, so this will be equal to d square minus 0.64 d naught square divided by d square. This we will get here. So this is the weights. Now we need to further simplify, because we know we know that diameter of the solid shaft we are calculated 122 millimeter. Here also we can substitute, but we don't know the diameter of the outside diameter of the hollow shaft. Even we don't know inside diameter of the hollow shaft. So we need to calculate these two. Then we will get substitute. Then we will get the percentage saving of the material here. Okay. So just I'll write this one. That is d square minus 0.64 d naught square divided by d square. This I'll call it as equation number C. This is weight of solid minus weight of hollow divided by weight of solid into 100 equal to, here also into 100 we will get, into 100, okay, equal to, here into 100, okay, this in this all case into 100, so here also into 100, okay. So now to find di, this I write properly, d naught d square minus, okay. So to find di, this is di we are getting, right, because we substituted in terms of di, di equal to 0.6 d naught. So internal diameter equal to 0.6 times external diameter, right? So if you substitute, we'll get in terms of di here, okay? We'll get in terms of di. Now to find di, so di equal to 0.6 times d naught, right? So we need to find out d naught. Given, he is given here, that is what is the condition is given? The torques are same, and shear stresses are same, lengths are same, material is same, right? So torque for both solid and hollow are same. Therefore, torque of solid equal to torque of hollow. I can equate. What is the equation for the torque of solid? That is pi by 16 torque of solid into d square equal to pi by 16. This is d raised to 4. This is d raised to, we already calculated here, right? This we are already calculated here. Torque of solid, we can substitute the what is the value? 2864 7.8 into 10 raised to 3. This we are already calculated into pi by 16 into tau, that is d naught. What is the formula? D naught raised to 4 minus di raised to 4 divided by d naught. Okay, so here also we will substitute di in terms of d naught. Okay, so di in terms of d naught, substitute here. This will be equal to pi by 16 tau. What is the tau value? That is, he said that both the shear stresses, maximum shear stresses for both material, it will be same. So what is the shear stress here? 80. Okay, that is 80 into, that is d naught raised to 4 minus di is in terms of d naught, 0.6 d naught, that is 0.6 d naught raised to 4 divided by d naught. So here 2864 7.8 into 10 raised to 3. Okay, so this is here, this equation contains only one unknown data, d naught. Simplify it and calculate the d naught here. Okay, so after calculation we will get the d naught value equal to the 127.6 millimeter. So this will be nearly equal to 128 millimeter. This is d naught. So when once find out the d naught value, di is 0.6 times d naught. Therefore di equal to 0.6 into d naught is 128. So this will be equal to, di value is 76.8 millimeter. This is inside diameter of the hollow shaft. Now come to the here this equation. This one as, I'll call it as this equation D. We know the diameter of the solid shaft is here 122. The diameter of the inner shaft is, we are already calculated 76.8 and d square here. Okay. Therefore substitute. Therefore equation D becomes, now you know all the values. D becomes, so weight of solid shaft minus weight of hollow shaft divided by weight of solid shaft into 100 equal to, d square is 122 square minus 0.64, di is the 76.8 square divided by d square is 122 square into 100 into 100. So simplify and calculate the how much weight we can save here. That will be equal to 29 point, if you simplify we will get 29.55%. Okay, 55%. So this is the final answer. Okay, so if you replace the solid shaft with the hollow shaft, you can save the material by 29.55%, almost the 30% of the material you can save here. So this is one of the design criteria required. So almost they will maximize the material reduction in the industry. What is the possibility to, if you replace the solid material into hollow material, that they are looking here. So this will be helpful while saving the material here. Okay, so you can save the 30% almost of the material here.